doesn't look like it, showing like we have a third left, but I think we covered the majority of the material already. For example, we already know what a sentinel value is. The sentinel value is just a piece of data that indicates the end of the series. It's a special value that can't be confused with real data, right? Like -999 or type Q to quit, that kind of thing. So you use that for indefinite loops when you user or we don't know how many values will be entered. It's real easy if you know you have to enter 7 days worth of sales every time. But what if we don't know how many days worth of sales we're going to enter? Deciding which loop to use, while loops, do while loops, or for loops. Now let's say this one first. Do loop, since it's a post-test loop, it always iterates at least once. And in their opinion, that's a good thing for handling menus. If you have a loop that the body of it always has to execute at least one time, use a do while loop. For loops are great if you're stepping through a series of values or items. Otherwise, use a while loop. If you're creating a counter, or if you're stepping through elements in a list and an array, then use a for loop. If the body has to execute always, at least once, you might use a do loop. Otherwise, use the conditional pretest loop, the while loop. So it's kind of like, this is kind of a specialized one. This is the best one, in my opinion, the for loop, because of the syntax, because it's got the built-in expressions for initializing, testing, and updating. And then the fallback, the one that you can always use because there's nothing you can implement with these two that you can't implement with one of those. Nested loops. Nested loops are when you have an outer loop and then you have an inner loop. So we might want to write a little loop. Did we do the multiplication table last Tuesday where we print out the numbers times the numbers in a grid? I don't think so if we hadn't been talking about nested loops yet. Does anybody get a nod there? No? All right. So we might want to load up Visual Studio and do that. But here we go. For example.
I think we actually did.
You think we did do the multiplication?
It was like in columns, right?
Right.
Yeah, we did that.
Okay. Okay. So we have our example, and I may as well get Visual Studio loaded anyways. Need it sooner or later. Here we're entering a certain number of students, right? For int student is equal to 1, keep going while we have not hit the number of students. And then for test is equal to 1, keep going while we have while we still have tests to go. Ask for their test score, add it up, calculate the total. This is the inner loop, and it's going to keep repeating over and over and over until it's done, until the inner loop is completely done. Then we can print out the average for that student, and then it'll iterate the outer loop and ask us for the next student. Keep doing that over and over. Repeats this over and over, and then it comes back out and clicks, iterates once to the outer loop. Repeats this over and over, gets to the end, iterates the outer loop. Keeps doing that until we have processed every piece of data. And if we are correct in recalling that we did a nested loop that printed out the multiplication table, 1 to 9, something like that, some kind of data separated in rows. So we had an outer loop controlling our rows, and we had an inner loop controlling all the columns. And in order to print our table, we had to print every column and then go to the next line. Print every column, go to the next line. So the inner loop had to iterate all the way, every iteration, before the outer loop would iterate once. Best way to find out if we did that already is just to go look. I'm not seeing the example in the sample code. I thought we had done it, but I'm willing to do it again. It won't take long. All right. So we're going to do the rows and columns thing. If it's a repeat, great. We're burning it into our brain a little bit better. Maybe I just lost it out of my notes.
It's lecture S. That's what I have it under.
When I'm looking at lecture S, why don't I see it? I guess I uploaded the wrong version of lecture S. So this is lecture T, if I'm correct.
Yep.
Okay, we'll try to make this one look a little bit different than the straight multiplication table, just so that we have a good excuse for having done it already. All right, fine. But just to be doing this a little bit differently, we may put this function inside of a namespace. Probably be even more valuable to put it inside of a class, since we haven't talked about classes much. So yeah, I'd like to put it inside of a class. So a class is a collection of data with functions attached to it known as methods. Our class isn't going to have any data in it yet, but it's going to have some functions in it. Let's just call this class example, because I'm not coming up with a better name for it. Class example. And right now it's going to only have one function, which is the one that prints out the table. It needs to be a public function, meaning that it can be called from within main. If we marked it as private, we would not be able to call it from main. So public colon. All right, this is all looking kind of alien, but we've talked about structures, and structures followed the same syntax, right? It had the word struct there, and had a pair of curly braces. It ended with a semicolon, except everything in a structure is already public, so we didn't have to use that keyword. And let's call this one print table. Void print underscore table, parentheses in parentheses. Heck, let's make it accept two arguments to fill in parameter variables, the number of rows and the number of columns. So inside the parentheses, int rows, comma, int calls. Open curly brace. Now we need a nested for loop. For parentheses, int r is equal to 0, r less rows, r plus plus. For parentheses, int c for column equals 0, c less than calls, semicolon, c plus plus. Yeah, I remember doing this. I don't know why it's not in the notes. All right. Good idea. Feel free to turn it at an angle too. Now we're going to print out r times c. Why don't we start them off at 1 though? And why don't we make it less than or equal to? I've made a few careless mistakes here. I'd like my multiplication table to start with 1 and go up less than or equal to the number of rows and less than or equal to the number of columns. So C out, arrow, arrow, R times C, arrow, arrow, quote, backslash T. Absolutely sure we did this. I'm absolutely sure you're correct. And by the way, I made the syntax here wrong. Not equal, less than. I just put my cursor in the wrong place. It should be C less than equal calls. Outside of the inner loop,
I need to print the character turn to go to the next line. So I need to see out in ENDL. See out, not CPIT. See out, error, error, ENDL. So that's my class. And down in main, I'm going to run my class. To save a little space on the screen, I'm going to put the code on the same lines as the opening curly brace, like that, just to save a little bit of space. The curly braces are still there, don't ignore them. I just needed to be able to come down here. Alright, so I need to create an example. I'm going to make an example out of you. Alright, so example EX, and now I want to print the table. So EX.print underscore table, and I want it to be a 5 by 4 table, 5, 4. If I was being a good programmer, I would put this class in its own CPP file. I would make a file called example.cpp. And I would put a prototype of the class inside of example.h. But I don't want to make this overly complicated when we're not even doing a chapter on classes yet. So after it runs, it should print out our little multiplication table. Boom, there's our multiplication table.
That means a 5 by 4 table.
Turns out to be 4 by 5. Apparently, the first number is the number of rows, right? 1, 2, 3, 4, 5. And the second one's the number of columns. Now, the way my brain works, when I think 5 by 4, then I mean the number of columns first and then the number of rows, right? So if I wanted to, I could swap these values, right? I could edit the parameter names and make that int space calls, comma, int space rows. And then it would match kind of my expectation of what those things really mean when I created their, 5 columns by 4 rows. But it doesn't matter. As long as you know which is which. All right, I like that. Here's my 5 by 4 table. So this is the same syntax we've been using all along to write a function. It's just been embedded inside a class. A class is a template for creating a variable. So we created a variable called EX, and then we called the function that's part of that class. A function that's part of a class is called a method. So we called the print table method. And we passed in 2 arguments. We passed in a 5 and a 4, which filled in these parameter variables. So it looks pretty much like stuff we've done before, it's just that we put it in a slightly different framework. We stuck it inside a class. In some languages, like Java and C#, absolutely everything you create is inside a class. There is no main method that's outside of a class. You can't get away with putting code outside of a class. Absolutely everything goes in a class. But those languages came after C, C++. Anybody need typo correction? If this C out ENDL was inside the innermost loop, like that, then our data would look ungood. Right? We have to complete the inner loop before we go to the next line. So that's not the right place to put it. And this next mistake is real easy to make. What if I put it here? Right? Just because you have all these curly braces, it's easy to make this mistake. What if you put it there? Well, in that case, it's never going to hit the character turn until it's all the way done, right? Kind of the opposite, right? So maybe it would have been easier if we'd added some comments, and I don't do this often enough in my examples. This is the closing brace for the method, right? So end print underscore table method. This is the closing brace for the R loop. End for R. This is the closing brace for the inner for loop. End for C. Then it would have been real easy to see, right, when you were following along or whatever, where that needed to go. I should have done that rather than wait until somebody had a problem with it. And this little bit about putting everything on the same line was just so I could try to squeeze the example code down here at the bottom. Now that I've written the code, I want to kind of flip it back out the way I would prefer to see it. So the inner loop has to complete all of its iterations before the outer loop can tick once, iterate one more time. That's why we printed out all those numbers and then hit the return key by hitting ENDL. So the inner loop repetitions complete sooner than the outer loop? Well, that's absolutely true. The inner loop goes through all the repetitions for every repetition of the outer loop. And the total number of repetitions is the number of repetitions times of the inner loop times the number of repetitions of the outer loop. Now that can be hard to figure out if they're indefinite loops, right? We don't know how many times each one's running, but here's pretty easy, right? If it's 5 by 4, then we're going to print out 20 values, right? 5, 4, 20 values. Using files for data storage. Instead of printing to the screen or reading from the keyboard, we can write to a file or read from the file. And this causes a little bit of a pain for the Mac users. Just finding those files if you're using, is it called Codebase on the Mac? Who's using a Mac right now? I know that some of the people watching at home are, so I'm going to have to go and find how to fix the thing that I'm thinking about. Okay, so anyways, once we are done with the code that we have, we ought to be able to print to a file as easy as doing this. I'm going to use the word fout rather than cout. Fout, arrow, arrow, quote, look, I'm printing to a file. \n. Now, we haven't set it up to do that, but it ought to be that easy. Or reading in from a file, fin, arrow, arrow, read into my name variable, right? C++ is a strange beast. These stream IO operators, never seen in another language, but they make it real clear that writing and saving to a file and reading from a file, as long as it's a text file, is as easy as doing that. So that's going to be our goal. That's what we want to do. We could print our table to a file if we wanted to, rather than save it to a screen. Well, let's learn how to open a file so that we can start writing to it. I am recording, right? Okay, good. So your steps, you open the file, you use the file, either read from it, write to it, or both, and then close the file. You always want to close the file as soon as possible. As soon as you're done writing to it, you want to close it. Otherwise, the operating system may have a lock on it, meaning that if you try to copy it to a, floppy, a USB drive or something, or it needs to be backed up, it'll be skipped. So, to use file, we have to include a new header file called fstream. We might even modify our boilerplate to have fstream, and there's two different types. Three different types. There's ifstream, standing for input file stream, and there's ofstream, standing for output file name. And you use those to create what are known as file stream objects. We want to create an out file. We use the ofstream class to create an out file. Now the variable names don't matter, right? You could call that one Fred. We're going to write to Fred. Yeah, that does matter a lot. That's the name of the class that allows us to save to the file. So opening a file. You got to declare your object, and then you call .open on it. And you pass in a path. The path can be a simple file name. It could be a fully qualified path, like with the C:/ my directory / whatever. If you do the out file syntax, it will create the file if it doesn't already exist. And if the file does exist, it'll blow it away. It'll erase it. The input file must exist for open to work, right? How can you open a file for reading if that file doesn't exist? So it's better if the out file doesn't exist. It's mandatory for the in file to exist. Let's open up a file. We better go and add a # include fstream up at the top to get this to work. So to use file streams for input, or I'm just going to say for I/O, you must include, not unclude, fstream inside angles and use the ifstream or ofstream classes. So I'm going to scroll up to the top and put # include fstream. # include fstream. By the way, what's that public keyword for? If I comment this out, this isn't going to work anymore. Don't comment it out, it breaks it. It says print table is inaccessible. It can't call it anymore. If you've done Java, you're used to seeing the word private in front of your methods. Well, that same keyword exists in C++. What that means is you can only call that function, that method, inside that class, not from outside it, not from down in main. And so that's kind of dumb in this case, right? I don't want to call it from inside that class. I want to call it from down in main. So everything defaults to being private in a class in this language, unlike Java, where everything defaults to being almost public. For you two students in here who are learning Java at the same time as you're learning C++. So I should not have made that change. I'm going to leave that as public. All right, so I've included fstream. Now down here, I'm going to go and create an fstream object. Fstream FOUT. They liked output file or out file. I like FOUT because it kind of looks like COUT. Now let's create our file. fout.open parentheses. What am I going to call my file? I don't know. Lecture T2.txt. I'm going to make it a TXT file so that I can open it with Notepad. Let's write some stuff to it. We ought to check to make sure that it worked. So if parentheses fout in parentheses. I'm not sure if that's the way to check if it works, so I'm going to skip that for now, and then when we get to the next slide, we'll confirm whether that works or not. So fout, arrow, arrow, this is a text file, \n, end quote, semicolon. Fout, arrow, arrow, quote, pretty cool, exclamation mark, \n, end quote, semicolon. Now I'm going to add a message saying that I wrote to the file, just so that the user knows that we saved to the file. Cout error, error, quote, saved to file, \n, end quote. It'd be nice if we said what file we were saving to. Honestly, that file name should have been stored inside a variable to make it easy to print, but I didn't, so I'm just going to say saved to file lecture t2.txt. Then I better close it. You always want to close your files as soon as possible. So fout.close. Why does this one say cout and the other one say fout? What would happen if I changed that cout to fout on the highlighted line? Right, it'd write it to the txt file, and we don't want to store that message, save the file in that file. We want to see it on the screen. So that's why we use console out there, cout. All right, so save to file lecture2.txt. Lecture T2. Okay, I'm going to go find that file using the magnifying glass. Lecture T2.txt.
Oh god.
It's not finding it. It's bringing up Internet Explorer.
Oh god.
All right, so I'm going to go and find it by hand. It's just going to be in the Visual Studio project directory. So documents, C++, nope. Visual Studio 2017. Why am I spacing out? Where are my files stored?
It's in user.
It's in my user directory.
So your C drive
Really? All righty.
and user.
It's gonna be public, right? Or would it be under all these other?
No, it's
All
whatever
right.
account you're on.
I'm going to find it the easy way. I'm going to go to View, Solution Explorer, come over here, right click, open folder in File Explorer, and ta-da. It was in JG Thompson /source /repos /lecture T2. What a silly directory. I guess I hadn't been uploading my CPP files. So if I go and look, like in the debug directory, I should see my txt file, but I didn't. Maybe it's in the source code directory, lecture T2. Still not finding it.
It's in source and then the debug. Or sorry, it's in the let's see, the lecture T2. Go in there and then the debug it out.
Thought I looked there. Well, where are you saving yourself to?
You think just flat out making your own text file the easy way would probably work? Because I'm lost too.
But Simon, you found it on your machine?
Yes. It's in user assignment source repos lecture T debug.
Okay. Well, I'll find out real soon because I'm going to open a command prompt, cd into that directory.
There is the text file. It doesn't have the correct text. It's not.
And then I'm going to do dir star.txt /s/b. Well, where is it?
Never mind. I saw it wrong. I do not have a file.
Yeah, I can't find it anywhere here.
Okay. I guess this is the first time I've taught it on the Windows 10 computer. Is it? Well, where are you putting yourself? dir lecture t2.txt /s/b. Uh-huh. All right. We're going to try a little experiment. String fname equals, quote, output.txt, end quote. You know what I did wrong? Is it should have been an OF string for output file. Maybe that's going to make all the difference. Let's find out. Go back to my Solution Explorer, right click on it, say Open Folder in File Explorer, And there he is. Okay, it's because I didn't make it an OF stream. I have no idea where it was making it or if it was even making it, but it didn't give us an error. Okay, I'm really embarrassed I did that. Use OF stream to create an output file. Let's do it again, but ask the user for a file name to save to. So let's make a string fname, semicolon, cout error error quote, enter file name to save to, space, greater than. I've just gotten fond recently of using that to tell the user where to type, end quote, semicolon, cin error error fname. Now let's open that file. Make it an OF stream, unlike your absent-minded professor. I could reuse the variable fout, or I could make a new one. I guess I'll call it outfile, just like the book does. And an outfile.open, parentheses, fname. Let's ask the user for some data to save to it. So let's declare a string called data, or an integer. It doesn't matter. Let's make it an integer. Int data equals 0, and our sentinel value is going to be -1. So int data is equal to 0 while, parentheses, data not equal -1. Cout, enter a score, or -1 to quit. Space, greater than, colon, quote, semicolon. Now let's let him type it in. Cin error arrow data. And if the data is not equal to -1, we're going to save it to the file. So if parentheses data not equal -1, in parentheses, outfile arrow arrow. Outfile arrow arrow data arrow ENDL. The ENDL is just to get it to the next line. If we didn't want lines next to, if we didn't want pieces of data, each one on their own line, then we might separate them in spaces instead. However, since this is a text file, you definitely want to put an ENDL at the bottom of it, if nowhere else, or else when you edit the file with Notepad or something like that, it wouldn't display it. Notepad requires at least one ENDL in the document. Alrighty, after the close of the while, /end while, we're going to close the file. Outfile.close. Open parentheses, close parentheses, semicolon. Now everything we enter is going to be saved to the file. Enter file name to save to. t.txt. Enter a score. And I forgot to print a message. I always like putting a file written to message, and I forgot to, so I'm going to modify it to do that in a minute. 190, 180, -1. And it stopped. And I wish it had said file saved, right? It didn't. So we're going to go and add that. So cout error arrow quote data saved to space end quote error arrow fname error ENDL. We're just telling the user that we saved the data. What happens if we enter an invalid file name or an invalid directory? I'm going to pick a drive letter that doesn't exist as soon as I spot one. Do we have a Q drive? Nope. So I'm going to try to save to Q:/ something and see what it does. Q:/ t.txt. It thinks it's doing it. All right, we need a way to make sure that it actually opened the file because it's not generating an error when we try to save to a file that doesn't exist. So a later slide is going to show us how to do that.
Could you take a look at my notes?
Yep, let me pause and come eyeball. Here's something that's of vague interest to the Windows users, but it's not going to work on the Mac side, which is launching Notepad to get that file open. So we're going to build a command string that just says notepad.exe followed by the file name. Again, if you're a Windows user, a Mac user, or Linux, this is not going to work. Sorry, guys. String cmd, this is the command we're going to build. cmd equals quote notepad.exe space end quote. Make sure you get the space there plus fname. And now we're going to call system parentheses cmd. We're going to execute that command. System parentheses cmd. Now there's a way to do this on the Mac and on Linux. I just don't know the name of the editor. It didn't like that. No suitable conversion function. All right. Delete that. Delete that string cmd. Delete the cmd is equal to that. Delete the semicolon. In fact, delete all that. Just come down here, delete everything, and then type system space quote notepad space end quote plus fname. Close parentheses semicolon. Oh, and aren't you being a pill? All right. Last effort. Just system parentheses fname. And because it's a string, it doesn't like that. So let's get the character version out. fname dot c underscore str parentheses in parentheses. Now we could do the other part if we wanted to. We could probably add the notepad thing back, but and so save to something, but do add the .txt extension, t.txt. Type in some numbers, 10, 20, 30, -1, and then it pops open Notepad and shows you your data file. It's just kind of neat. I'd be curious. Mac user, go ahead and add that command. Add that system call right there, just like that. See if it works. Let me know if it works. Text me and say, hey, yeah, that worked.
So that command will work, but it won't pop open anything. From what I'm doing right now.
Okay.
Really cool.
All right.
Because it tries to run that as a command.
It tries to run txt, but it doesn't have a default thing for handling .txt. Okay. If we built a string that had the name of a text file editor, we could probably get it to work.
I tried just adding it like you were doing with the notepad, and just concatenating it, that didn't work either.
Right. Let me come back there and look. That is well worth mentioning. If you're using Linux, you're using something and you're getting an error on this line saying unable to convert from string to blah, blah, blah. You can fix that the same way we were trying to fix this down here. If you ever get an error saying could not convert string to basic string, just add .c underscore str there, and that just says, okay, extract a character string to pass to that function. Because in some implementations of C++, not all of the methods have been modified to accept the string class, and so we're just converting it to a character string there. And a character string is just a series of bytes with a null as the last byte. That's just about what we're talking about. Yeah, I would like to talk about character strings for a moment. Way down here, before our system pause, do this. Char name subscript 5 in subscript equals, and I hope I get the syntax right. If not, I'm going to bail out on this. Equals curly brace, quote, Fred, end quote, end curly brace. And now we're going to step through that string, printing out each character in it. This is what's known as a C string. Why? Because it existed in the C language long before classes came along, and the string class and stuff like that. So we're going to print out every character in it, all 5 characters in it. 5 characters, it only looks like 4. But the 5th character is a 0 because it has to know, if we did this, C out error error name, error error ENDL, it has to know when to stop. Forgot my semicolon. So it looks for that 0 at the end of the text. So let's write a for loop to do that. For parentheses, int I equals 0, semicolon, I less than 5, semicolon, I plus plus, open curly, C out arrow arrow I, arrow arrow quote backslash T, arrow arrow name subscript I. We're using arrays now, and we haven't really talked about arrays all that much. Arrow arrow quote backslash T, and I'm going to skip to the next line, but you don't have to. So after the end quote, I hit enter. Arrow arrow parentheses int end parentheses name. And when I say subscript, I mean square brackets. These are all square braces. I. Error, error, ENDL. So this was a pair of square braces right there after name there. This is a pair of square braces after name there. And what we see, well, I have to save to a file, t.txt, -1. All right. It's trying to, it wrote out the letters FRED, and it wrote out their ASCII values. If we go to ASCIItable.com, we'll see that an F is a 70, an R is a 114, an E is a 101, and a D being 1 less than an E is a 100, and then finally there's that 0 I mentioned, the new line, excuse me, the null, the end character. So if I go to Chrome and look up ASCIItable.com, I will see that a capital F is in fact a 70, a lowercase r is a 114, a lowercase e is a 101, and a d is a 100, and then a 0, a null is a 0. So that's an example of a character array, also known as a C string. I'd love for y'all to take the summer class on C. C programming is dramatically different than C++ programming. The C++ language is built on the C language, and anything you can do in C is compatible with C++. It's just you do completely different things. You do stuff like that. All right. So I'm going to make a comment as to the effect of what we're doing here, just because the topic came up. Demonstrate a C string, which is also known as a null terminated character string, which is an array of characters. What this means is that we have 5 characters stored in a variable called name. And the 5 characters are the 4 characters FRED, and the 5th one is the null. All right, let's go back to the real topic. But did I break anybody's code with that for loop and the square braces and all? We are good or not good?
For that system, well, it still works. For some reason, but it's just not correct because the system is ambiguous. It still works. But so soon as I started adding this stuff, it changed this. So, I don't know. Nope, I really don't know. Someone here just screaming out for another.
Is anybody else seeing the weirdness where it's underlining the word system?
Heck, maybe it is on mine and I just didn't notice. Nope. Is yours underlined red? Anybody else? No. Simon, you're special. But yet it's compiling and running. That's the mystery. So I'm hoping that the next slide shows how to verify that the file is actually open. Ah, just like that. If not in file, we're going to print an error message. Or in this case, not out file. So we could have done that up here. After we tried to open our file, we could have printed out an error. I'm going to leave that, but we are going to check it on the in file. Now let's ask for a file name and open that file for reading our text. So we have a variable called fname already. We may as well keep using it. Cout error quote. What file shall we read from? Question mark space greater than end quote semicolon. CIN error fname. Now we're going to use an IF stream. So IF stream space in file, or I could call it FIN, but I saw that that was causing some folks confusion between FIN and CIN, so I'm going to leave it in file. Now let's open it. In file.open parentheses fname in parentheses. And in your case, you're going to have to use .c_str there. But nobody else has to, unless you're getting an error there. All right, now let's check to see if the file was open. If parentheses, and this is a strange syntax, honestly, exclamation mark in file, in parentheses, we're going to print out an error. Cout error quote, unable to open, space, end quote, error, in file, error, ENDL. But if we didn't get that error, why is that underlining that? Is it just confused temporarily, and if I rebuild it, it's going to start working? Oh, it's right. What should I put there? That's supposed to be the file name there. My mistake. Sorry for the dummy mistake. Fname, right there, right? Because that's the name of the file that we're trying to open. So that should have been fname. But that's our error message. Maybe I could even put the word error, colon, right in front of it. But else, curly brace, good news. We could do stuff to it. We could read the file. There's different ways of reading the file. To make sure I show the most straightforward one, or what they make sure the most forward is, yeah, I'm going to come and look at their code. They don't show it. Yeah, thanks. Here we go. Again, the syntax is slightly odd, but we'll go with it. While parentheses in file arrow, arrow. Now I need a string to save this into, and I didn't declare a string. So I'm going to go up above here, above that while statement, and say string line, like a line of data, string space line. And then this is going to say while, parentheses, in file, arrow, arrow, line. While that works, let's print that to the screen. Cout arrow, arrow, line. Now, I don't recall whether that's going to include the ENDLs at the end of the line or not. We may go back and put in arrow, arrow, ENDL after that happens. All right, and then after our while loop, once we're done reading from it, we need to close it. So infile.close. And let's write out a message. Cout arrow, arrow, quote, finished reading from space, end quote, arrow, arrow, F name, arrow, arrow, ENDL. All right. T.txt is where I'm saving my data to, and at least put a couple of elements in there, 100, 200, 300, -1. Close your notepad. I'm going to wind up commenting that out. What file shall we read from? The same file, T.txt. And look at that. It printed out all the numbers, but it didn't print them one per line, and that's because it's leaving out the \ns. So I need to go and modify this line of code right here. And I'm going to comment out this system call. That's getting irritating. So I'm going to come up here and comment out the system call underneath data save to. Now I'm going to go back down here, and where we're writing out each line of data, arrow, arrow, ENDL. I guess we could make this even more clear. I'm going to modify this cout statement a little bit more. Cout, arrow, arrow, quote, data read, colon, space, greater than sign, in quote, space, less than, line, less than, ENDL. A little bit fancier, but T.txt, enter some numbers to read, to save to the file, -1. I'm going to read from the same file name, T.txt, and it writes 100, 200, 300. Now, if you're using a code bench or whatever on the Mac, the question is where is that text file? I dare you to go and find it. Instead, what you wind up doing, or what you need to do, is specify a path, a valid path, to your user's document directory or something like that. And I'll need to remember how to generate that. But anyways, there we go. We've read 3 lines of data. We could be adding those numbers together to calculate the sum or something like that, but I think that's enough for this example. So we've had 2 examples of saving data to a file, and we did 1 example of opening a file to read from. So for your homework assignment, I just want you to take a program you've written before and save its output to a file, right? Do the whole thing, but then save its output to a file. Maybe the BMR program, because that one had like the most file output, right? So the homework is going to be to modify the BMR program to save its output to a file. And it ought to save the whole thing, right? I mean, you know, you burn this many calories a day, that kind of thing, not just writing out a number. And you could display it to screen too, but I also want it to save to a file. Prompt the user for the file name. Let's write this as our homework. Homework, modify the BMR program to A, ask for the file name, B, open the file name as an OF stream, C, print the data, you know, save the data, same data that you displayed to the screen, to the file, and then D, close the file, and then E, print a message saying that you saved to the file. So really, that's probably not going to take too long, assuming you did that homework assignment. If you didn't do the BMR one, just pick another one that you did do and modify it to ask for the file name and then display some data to the file. That makes sense?
Makes sense to me.
Can I do one question?
Yeah.
So we've used OF stream and IF stream. What's
Right.
the difference? Is IF creating file and OF?
OF creates a file because it means output. So to create the file, and if the file exists, it'll delete it and recreate it. IF stream means input, which means that the file had better exist. If the file doesn't exist, we're going to get an error message. Very good question. Like if I ran it again, my output file is called t.txt, but my input file is called I don't know.txt, then it says error, unable to open I don't know.txt.
Got it. Thank you.
All right. I'm going to go ahead and stop the recording. Anybody else have any questions first? Nope. Nobody's making eye contact. I assume we're okay.